All right, so we're going to continue with section 13.1, and we're going to talk about the graph of a function and traces. So the graph of a function of two variables is the set of all points x, comma y, comma f of x, y. So the graph is just what you all have always thought of the graph as being. It's the picture of the actual function, whatever you visually see if you were to sketch the function. So given the graph of a function z equals f of x, y, a trace of f is the intersection of the graph of f with any plane parallel to the xy plane yz plane or xz plane. For any real number c, the trace x equals c is z equals f of, so your x you replace it with c, comma y, and lies in the plane x equals c, and the plane x equals c is parallel to the yz plane, so which is parallel to the yz plane. So if you see something x equals c, a trace equals x equals c that you have to sketch, and we'll sketch some traces in an example, that thing is just going to be something that's parallel. It's going to kind of look like the yz plane. We just slid over c units in the x direction. The trace y equals c is z equals f of x, comma c. So you just plug in your c for your y there. And lies in the plane y equals c, which is parallel to the xz plane. And lastly, and the trace z equals c is c equals f of xy. So you take your function and you just set it equal to the constant c. And lies in the plane z equals c, which is parallel to the xy plane. So in your MATLAB assignment, I had you all plot the traces for at least one of the graphs that was given in your problems. All right, so now let's look at an example. So I'm going to go to the next page so we can fit our example all on one page. So example, f of xy equals x squared plus y squared. And this is not an example out of the book. This is just an example that I'm giving you all. Or remember, you can also call that, excuse me, you can also call that z equals x squared plus y squared. Either one of those is fine. So first, let's just sketch some traces. So eventually, we'll know how to sketch this either just off of memory or off of like did we remember, or looking at a list of equations that are given in you all's textbook and then matching this equation to that list of equations. Or you may do traces. So the way that I do it is I do traces and I sketch things based upon the traces. So we'll start there, but you're welcome to use whichever approach you like. So trace x equals 0. So the trace x equals 0 says we're supposed to plug in 0 for our x, and that's going to give us z equals y squared. So the trace x equals 0 actually is in the xy plane, the zy plane, excuse me. And traces don't tend to be what we're looking for at the end. So the important picture tends to be the graph, but on occasion you might just be looking at a trace. So here, this is going to be a parabola that opens up in the YZ plane. So it's going to look something like that. All right, now let's look at the trace. And when you're using traces to sketch a graph, you pick whatever constant c that you want to use, and you don't have to use the same constant c for your x, your y, and your z. You use whatever is useful in helping you figure out what the graph looks like. And then also something that's fairly easy for you to figure out what that trace looks like as well. You don't want it to be a lot of trouble you figuring out your trace. So y equals 0, we put that in, we get z equals x squared, which is also a parabola that opens up, but this parabola is now in the xz plane instead of the yz plane. All right, and then we'll do the trace of z equals the trace z equals. Now here, if I'd say, okay, well, I want to do z equals 0 because I did x equals 0 and y equals 0. If I plugged in z equals 0 there, then I would get x squared equals negative y squared, and I would just get that all 3 points are 0. So I would just get one single point if I did z equals 0. which is not that useful in trying to sketch a graph. So that's why I wouldn't use that one. And you may start there and say, okay, well, that's just giving me 0, 0, 0, which is not that useful for me. So instead, let's use something else that's going to be more useful, and let's do z equals 1. And if we put in z equals 1, we know what that looks like. So that's going to be a circle of radius 1 centered at the origin. And remember, we're doing a trace. We're not doing in 3 dimensions, because of course in 3 dimensions, x squared plus y squared equals 1 is a cylinder. But we are stuck. When we're doing a trace, we're stuck in this plane z equals 1. So we don't have a cylinder. So here, we put that in, we get x squared plus y squared equals 1. So what I'll do, because we're not in the xy plane, I'm going to sketch it. Those in the xy plane, of course, but specify, well, this specifies we're in the plane z equals 1, so I don't need to specify that again, but I'll put, let's put parentheses around the x and the y, since they're not actually the x-axis and the y-axis. And then we would just have this circle of radius 1 centered at the origin. All right, so those are the 3 traces that we chose to sketch. So now these 3 traces, if we look at them, so if we were to look at this, whatever this thing is, z equals x squared plus y squared, if we were to look at it, we were standing on the x-axis and we were to look at it, it would look like a parabola. Then if we were standing on the y-axis and we were to look at it, it would also look like a parabola. But if we were standing on the z-axis looking down at it, it would look like a circle. So now, does that help us figure out what does this thing actually look like in 3 dimensions? You just kind of resketch your traces to an extent in 3 dimensions. So now in 3 dimensions, so in 3 dimensions in the YZ plane, it's a parabola. So I'm going to just sketch that parabola in the YZ plane. Now remember, when you sketch stuff in 3 dimensions, not to put arrows on it, on whatever your sketch is, because it'll get quite confusing and you wouldn't, there will be a lot of more arrows than you could actually draw anyway that would be necessary. So in the YZ plane, that's what it looks like. Now in the XZ plane, it looks like that as well. So I could like sketch a little dotted parabola right here, but I'm not going to do that yet. First, let's just look at what does it look like at z equals 1. And it doesn't matter what value you put in here as long as it's not 0. I mean, of course, it has to be positive, but if anything that's greater than 0 that you put in for z equals 1, it's going to look like a circle. It's just the radius of the circle will get larger depending upon what the larger the value c is that you choose right there. So here, if I were to look at it from above, we know this thing looks like a circle from above. So now, using those 2 traces, the trace x equals 0 and the trace z equals 1, we can kind of visualize our other trace in there and don't necessarily need to sketch it. So what we get is, you can sketch that other trace if you wanted to. It would just look like kind of like a little dotted line right here. Well, actually, that wouldn't be dotted. That would be dotted. And that would be solid. So if you wanted to, I rarely sketch that other trace though. If I don't need to, I sketch whichever ones I need to sketch to visualize what I have. And this thing is called a paraboloid. All right, so we'll stop this video here, and then in the next video we'll do some more examples where we either sketch or we identify what the function or whatever the graph is or function is that we're given. So sometimes I may ask you to sketch, sometimes I just flat out ask you to give it to me by name. And now if you see something that looks like similar to this. Um, Similar being that the z's on one side by itself is not being squared or doesn't have a square root or anything on it, and then the x and y terms are both squared and they're on the opposite side, both of which have positive coefficients, then you know that thing's going to be a paraboloid in some shape, form, or fashion. And there's a list of equations in your textbook that provide the picture, the name, along with that equation. So we'll look at some more of those in our next video.